So here two routers. Are you guys there?
Yes, sir.
Yes, sir.
I think my screen is not visible for you guys.
Yes, yes, not visible.
Lakshman, router on work on which layer?
Layer 3,
And switches,
layer 2,
ARP work on which layer?
layer 2, layer 2.
Okay. Why
2.5 layer. 2.5 layer.
ARP is called as
But
a 2.5 layer?
Because it doesn't
because
work.
it can also, the router can also receive our request cannot read it, but it works within. The reason is first, our request cannot work only. It will be generated only within the local area network. Also, router has the capacity to receive our request, so it is called as a 2.5 protocol. Router default gateway will receive the ARP request. Also, ARP request only generated within a local area network. So router and switches plays a role. So it is called a 2.5 layer protocol. Uh, Sir, it's correct or wrong?
Yes. Subhaji, why it is 2.5?
Because it works with layer 2 and with layer 3 also. So when the MAC address, when it resolves the MAC address, it works with ICMP protocol and ARPA protocol both. So it is 2.5
ARP,
layer protocol.
ARP on ARP, or ARPA.
ARPA is 2.5 layer
Uh,
protocol.
okay. ARPA is different from ARP. How? What is the work of ARPA?
Uh, like our protocol will help to create the ARP request, where ARPA protocol is responsible to send this ARP request to different networks to fetch the MAC address and IP address.
Okay. I told you ARPA protocol is the obsolete version of the DNS.
Yes, yes, sir.
So here are two routers, R1 and R2. Two PCs are connected. One is from R1, one is from R2. Suppose that it's connected with a serial link. Okay. So Lakshman's question, why R2 is giving a proxy ARP response to R1? Let's suppose Lakshman, here it is OA, here it is OB, OC, OD, OE, OF. Okay, is it clear? So let's suppose R1 is asking to R2 to give a for the MAC address of 20.0.0.1. It is sending a packet just, and in which source IP will be this gateway's IP, destination IP will be 20.0.0.1, source MAC will be OD,
CROD, OD,
destination MAC will be
uh, FFF. No, 00. It will be unicast.
okay. Now R2 receive this packet in its 0 by 0 interface, gig 0 by 0 interface. R2 will check the destination MAC. It will get that destination MAC is 00000. So it will understand that R1 doesn't have the destination MAC. And then R2 will get the destination IP. What is the destination IP in the packet?
20.0.0.1.
20.0.0.1 is the destination IP. Okay. Now R2 will understand, check in its routing table. R2 will check either 20.0.0.0 network is present in my routing table or not. So this network will be here 20.0.0.2, the gateway interface. So R2 will get this network in its routing table or not, Lakshman?
I think not, because
R2
R2 will get, sir, because it is directly connected.
directly connected will get, okay, in its routing table. So R2
Yeah.
will understand that this packet is for 20 network and it is present in my routing table. So if R2 will drop this packet, is there any other method that R1 will get the path? If R2 will drop.
Sir,
Yes.
could you please repeat one more time?
If R2 will drop this packet, it is seeing that this network is present in my routing table. And R2 if drop this packet, and if suppose that R2 is not replying to R1, then R1 will get any other method that R1 can get the destination MAC?
No.
No. Let's suppose in another example. Suppose here R1, R2, R3, and let's suppose R4, and here it is a PC2, here it is PC1. If I have configured static routing, then R1 knows, R1 knows That 20 network is present on this interface in IP routing. IP route 20.0.0 to 55.255.255.0 gig 0 by 0. Is it correct? Is it correct, Lakshman? This command.
Yes.
Okay.
Yes, sir.
Then R1 will send this packet from this interface only, because router never do a broadcast. It will not broadcast any ARP on each and every interface. Okay.
Yes, sir.
Okay. R1 will send an ARP request unicast to R2, and R2 will send yes, it is present. This network is present in my routing table. So that is why R2 is replying to R1 as a proxy R. If R2 will not reply and drop this packet, there is no way to reach out the destination.
Yes, sir. Understand.
Understand? Ravi Shankar and Subhajit.
Yes, sir.
Yes,
Clear?
sir. Clear. Yeah.
Yes, sir.
So, Lakshman, any query you can ask me.
Uh, Till now,
100%.
no, sir.
100% clear.
Yes, sir.
Okay. In an interview with Orange, they asked me this question in year 2020 or 21. You know the Orange? Okay.
Don't know, sir.
So till now we have discussed about the proxy ARP. So Ravi Shankar and Subhajit Lakshman. So now do you guys have understand how this is replying to R1?
Yes, sir.
Okay. On this step, this is clear. So one ICMP packet drop here and one ICMP packet drop here. And now R1 got the reply from R2. And R2 is replying to R1 that source IP, suppose that R2's source IP here 10 dot, no, 11 dot 0 dot 0 dot 1. So source IP will be 11 dot 0 dot 0 dot 1. Destination IP will be in R2 proxy or packet. This one will be the destination IP 11 dot
Yes, sir.
0 dot 0 dot 2. It is OA, OB, and OC. So source MAC, OD, OE, OF. Source MAC will be of this interface. OD, this is the content of proxy ARP. And destination MAC,
Yeah.
OC, OC, because ICMP packet is here.
Yes, sir.
Okay. Now R1, what will R1 do? R1 will send an now R1 has got the proxy R reply, and now R1 will send this ICMP packet to R2. Guys, try to understand. ICMP packet generated by PC1 and firstly drop on PC1. Then second time it reaches to R1 and it was hold on R1. Okay. and R1 get the response to the R2, and now R1's ICMP packet may be drop because R1 ICMP packet lifetime is only 2 seconds. Okay, now PC1 will generate another ICMP packet, and R1 will forward this ICMP packet to R2. So now when this ICMP packet will reach to R2, R2 will check that either I have the OF or not. Then R2 will not able to get the MAC address of this PC. Will R2 have? Does R2 have any MAC
No,
address information in its MAC table?
no, sir. No, sir.
No. Now R2 will hold this ICMP packet and will generate an ARP request on this interface because 20 is connected on which interface? Destination IP in the ICMP packet will be source IP will be in the destination. Source IP will be in the ICMP packet. It is 10.0.0.1, 10.0.0.2. It is 20.0.0.1. It's 20.0.0.2. Source IP will be this one. Destination IP will be Lakshman. IP ICMP packet reaches here. Destination IP will be 20.0.0.1.
Um,
Source MAC will be 0,
oh, yeah.
8,
Oh, yeah.
and destination MAC
Hold. And 0,
0 because it doesn't know.
O, E.
Unknown.
O,
Okay.
mm,
Now
okay.
Now this in this ICMP packet, R2 will get that yes 20 network I have in my routing table, and it will check on which interface the 20 network is connected. It will see the routing table and will get to know that R2 is connected on this interface only. Okay. Now it will check in its ARP table that either I have the OF or not. Either I have the PC2 20 networks 20.0.0.1's MAC address or not. So it will get to know that I don't have the MAC address. Then it will R2 will generate R2 will put this ICMP packet which is generated by P1 on hold and will generate an ARP request to PC2. Is it clear? Or should I repeat?
Yes, sir.
Lakshman, Ravi Shankar, Subhajit. Guys, please respond.
Clear, sir.
Clear?
Okay.
Okay. Now R2 will reply to R2 will ask to OF. So source in the ARP request which is generated by R2. The ARP request should be generated by R2. The source MAC will be source IP will be source IP will be this IP, this interface IP 20.0.0.2. Destination IP will be this one.
20.0
Source MAC will be
OE
destination MAC will be
OF.
no.
Hold. No, no.
Okay. Now this ARP request will reach to OF. Okay. Now OF will get to know. Write down again this. Now OF will get to know that this packet is for me. because when it check the layer 3 information in the layer 3 destination IP is 20.0.0.1. Guys, please.
Yes, sir.
Okay. So
Yes, sir. 20.1.
so what OF what PC2 will do? PC2 will give a ARP response. Will give a ARP response. And the ARP response will be source IP, Lakshman, source IP,
Yes, sir. IP will be 20.0.0.1.
destination IP,
Mm, yeah, that
20.2.
OE 20.0.0.2
source MAC,
OF
destination MAC.
OE.
So this ARP packet will reach to R2 and R2 will check, okay, on layer 2 that destination MAC is OE. So it will understand this packet is for me, okay, and it will check the source MAC. And when it will check the source MAC and it will check that it will get to know that destination that source IP is 20.20.0.0.1. So what will R2 do? R2 in its ARP table, in its ARP table, R2 will store 20.0.0.1 with OF, that this is the PC IP address and what is the MAC address of PC? OF. So for how much time a router can store the MAC address in its MAC table or R table? 4 hours, guys.
Yeah.
Okay.
Yes, sir.
Now the ICMP packet was on hold on R2. Okay. And it may
Yes,
be
sir.
possible that this process will take more than 2 seconds due to congestion on bandwidth on the link or something else. Okay, so it may be possible that this ICMP packet can be dropped on R2. It may be possible that within 2 seconds get the reply. Then now R2 have the destination MAC. So it will forward that particular ICMP packet on which interface? On this interface only. In that ICMP packet, what will be the source IP? ICMP packet generated by which device? This
The
device,
PC.
PC1. So source IP will be 10.0.0.1. Destination IP will be 20.0.0.1. Source MAC OA. Now destination MAC. Destination MAC. So R2 will not make any changes in this ICMP packet. Just forward this packet on this interface and it will reach to PC1. And when PC1 will PC2 sorry PC2 will see this ICMP packet and check the destination MAC, it will understand, okay, this device means the generator of this packet doesn't know about the MAC address, and when will get to know about the destination IP, it will understand this packet is for me. Okay, now PC2 will give an ICMP reply to PC1, not to R2. It will generate the ICMP reply to for PC1. And what will be the source IP address, Lakshman? Lakshman,
Sorry, sir. I got stuck with network issue. So
Subhijit, what will be the source IP? So Lakshman,
Yeah,
I am repeating it.
20.1.
1 minute. ICMP packet was on hold on R2. Are you clear with this point? R2 send a request for the MAC address, and now R2 got the reply from the PC2. Lakshman,
yes, sir.
now R2 get the reply from PC2. Okay,
Yeah. Yes,
and
sir.
it will create its in its MAC table an entry that 20.0.0.2 is with the MAC address 0f on an interface. Suppose that it's 0 by 1, 0 by 1 interface, gig 0 by 1. Subhajit, Ravi Shankar, is it clear? Lakshman, is it clear?
Yes, sir.
Yes, sir.
Now R2 will forward this ICMP packet on this interface, and it will reach this ICMP packet will reach to PC2, and PC2 on layer 3. So when it will check the destination IP address, PC2 will understand that this IP address is for me, and it will generate an ICMP reply. So in this ICMP reply, what will be the source IP? Subhajit.
20.1.
20.0.0.1. Lakshman, what will be the destination IP?
La, sir, it's 10.0.0.1.
Ravi Shankar, what will be the source MAC? Ravi Shankar,
OF, sir. OF.
OF. What will be the destination MAC, Ravi Shankar?
0, 0, 0, 0, sir.
No. From this MAC address, PC2 will understand that this is the MAC
Okay.
address of the PC1, and at the same time PC2 will create an ARP table, and in the ARP table it will generate an entry, create an entry that 10.0.0.1 MAC table with MAC address with OA and connected with it. Okay. So
Okay, sir.
in the ARP table it will create an entry. PC2 also destination MAC will be Lakshman in the ICMP reply from PC2.
OA.
OA. Now this ICMP reply will reach to R2. R2 will check the source MAC and destination MAC. After seeing the destination MAC, what R2 will do? R2 will check its ARP table. So now when this ICMP packet from R1 from PC1 reach to R2, then R2 what will do in its ARP MAC table, R2 will create an entry that 10.0.0.1 as the MAC address of OA. Okay, guys.
Yes, sir.
Okay. Now R2 will
Yes, sir.
understand this packet is not for me, it's for 10.0.0.1, and it will check its routing table on which network on which line this network is connected. So it will get to know that on this 0 by 2 interface I am connected with 10 network. So it will forward the ICMP packet to R1, and this packet will reach ICMP reply will reach to R1, and R1 will check this packet, and when the source MAC, destination MAC, and source IP, destination IP, R1 will check. R1 will get to know that this packet is not for me, and this packet is for 10 network, and this 10 network is connected with my which interface? Let's suppose it's 0 by 0, so it is 0 by 1 interface. So it will forward the ICMP reply. R1 will forward this ICMP reply to PC 1.
One.
And PC1, when PC1 will get this reply with ICMP reply code, so PC1 will get to know that this packet is for me and this is an ICMP reply, and it will accept that packet. Okay, guys, this
Sir.
is the entire packet flow. Lakshman, Subhajit,
Yes, sir.
did you guys understand the process? Give me a bold reply, guys.
Yes,
Any
sir.
doubt you can ask
Understand.
to me. Subhajit, Lakshman, Ravi Shankar. Ravi Shankar,
Yes, sir.
did you understand the entire
Ah, sir.
packet flow?
Ah, sir.
Lakshman,
Yes, sir.
I think you are a little bit confused.
Sir,
Yes,
can we perform this on packet tracer?
yes, I will do in the
Uh,
packet tracer, but on the
by
Eve only I can show you the entire process. I will do it on the packet tracer. Okay, let me open it on the packet tracer. Just wait for it. I will show you how the ICMP packet is dropping on the packet tracer. So Lakshman, if you are traveling to, suppose from Kanyakumari to Chennai, if you
Yes, sir.
don't know the path, first time you are going to Chennai, will it take more time
Yes, sir. It
than
takes more time.
expectation? Uh, and if you are traveling second time and you are knowing the path, then
The timing will be reduced.
okay. Just a minute, I am opening the packet tracer. So my screen is visible, guys. Is it visible or not?
yeah,
Yes, sir.
yes, sir.
Visible.
Visible.
I really apologize for the last 2 days. So
Yeah.
because I wanted to finish OSPF and Eigrp within this week. Should I increase the font size or you guys are able to see it? 11.0.0.1. Guys, please give me the reply.
No, sir. We can visible.
Lakshman, did you search about the MAC address?
Yes, sir. First, we need to go to the specific interface and enter the command MAC address. Then we need to type the MAC address.
Yes, exactly. Okay, guys. So guys, first of all, what you will need to do, you will need just to and go into the enable node. From enable node, configuration mode, and interface. Sorry, interface gig 0/1. Now, no sh command. What will the IP address, Lakshman? Are you there, Subhajit?
Yes, sir. The like
Yes, sir.
we
Approve
have
it.
to output.
What will be the for? I am doing it very fast.
Yes, sir.
I am recording it. You can see in the recording.
Yes, sir.
IP address 11.0.0.1. Now simply I am going to configure IP routing here. Static routing. So, gig 0/0. 12th interface connected with which interface? 12 network connected with which interface? Guys, 0/0 only. 10 network will 0/1 only.
Yes, sir.
So static route has been configured here. So now I'm coming on here. interface gig 0 by 0. Lakshman, are you there?
Yes, sir.
So what will be the IP address on this interface, Lakshman?
Yeah, it's 0 by 0. It will be 11.0.0.2 255.255.255.252.
Interface gig 0 by 1. No SH. IP address
12.0.0.2 or 1. Okay.
IP address is spelling mistake. It will be 2, not 1. So let me configure the IP route also. IP route 10.0.0.0 connected with which network? Connected with which interface? Sorry,
0.
gig 0 by
0.
0. 11 network connected with which interface?
0 by 0.
12 network connected with which interface?
0 by 0.
12 network, Lakshman. 0 by 1 only.
0/.
0/1 is a 12 network. Sorry.
Now, let me ping from this PC 1 to PC 0. Going in the command prompt, writing first ping 10.0.0.2. You are seeing request timeout means ICMP packet drop. Second request timeout means second packet is also drop. Let's see for the third packet, it's also drop. Now for the fourth packet, it is getting a reply from 10.0.0.2. Is it clear, guys?
Yes, sir.
Okay. Now if we ping from PC 0, now this is second time the packet will ICMP packet will traverse between PC2, PC0 and PC1. So it means it already has the knowledge of the path. So if I will send this packet, what is the PC1 IP address? 1. Now the ICMP packet will not lose. It is showing that this is unreachable. Why, guys?
Sir, check the IP address 1 second, like whether it's a correct IP address or not.
1 minute. Default gateway 10.0.0.1 and IP address is 10.0.0.2.
Destination IP address like PC2.
I have
12.0.0.
written 12.0. Sorry. Just now second time it has the information of the entire path. It is getting the reply. No packet drop.
Yeah.
Lakshman,
Yes, sir.
is it clear?
Yes, sir.
First time will be it will get the packet drop. Second time no packet drop because these devices has the MAC MAC address information in the ARP table and MAC table. So for how much time a switch can store the MAC address information? Maximum? Guys, please give me the reply. 5 minutes only,
Yes,
300 seconds.
4 hours.
PC and
Hello.
router can store for 4 hours, but switch can store only for the 5 minute, 300
Okay,
seconds.
sir.
We can increase the max aging time manually, but by default it is on the Cisco switches. It is 300 seconds only. Okay. So guys,
Yes, sir.
give me honest response. Did you guys understand the entire packet flow? Different subnet and same subnet? Is it
Yeah,
clear
yes, sir.
what is proxy R and why router using proxy R?
Yes, sir.
Subhajit, Ravi Shankar,
Yes, yes, sir.
Yeah.
Understand.
either it is a 10 router network. Suppose that 10 routers are connected with each other. Router 1, router 2, router 3, router 4, router 5. Let's suppose they are connected with each other. So, Lakshman, if someone will ask you to explain the packet flow from router 2 to router 6, will you able
Uh,
to give the reply? Because the process will be the same.
yes, sir.
Subhajit, in the
Sir.
same method, ARP request will generate same method, ICMP packet will generate same method, ICMP packet will drop, same method, ARP reply will get, same method, ICMP reply will get. Nothing beyond than that. And Lakshman, you were talking about DSCP packet flow. Am I right?
Yeah.
The
Yes, sir.
entire
But we are
mechanism will
taking
be
out.
the same for the DSCP also. The only
Okay,
thing
sir.
will change that DSCP port number in the packet.
Yes, sir.
Okay.
Yes, sir.
Now static routing and packet flow has been completed. Now the next topic is, what is the next topic? EIGRP. Anyone who knows about the EIGRP?
Sir, interior
No, sir.
gateway, sir.
Enhanced interior gateway
Interior
routing
gateway routing protocol.
used to share routing information within the autonomous system.
So Lakshman, do you remember I promised you guys to discuss about the autonomous system,
Ah, yes, sir.
because EIGRP use the autonomous system. That is why. So what is an autonomous system? Anyone want to explain? Who knows about it?
Not sir.
Not. Subhajit, do you know about the autonomous system?
Not much more, sir.
Okay, no issue. Ravi Shankar,
It like a zone.
Yes,
yeah, it's like a zone. It's like a zone, but not exactly a zone. Ravishankar, do you know about the autonomous system?
No, no.
No? Let me explain.
Uh,
Suppose there are n number of routers here. Suppose this is, uh, let me open a new slide, then it will be easier for me. Suppose it is Mumbai, it is Chennai, it's Hyderabad, and we have 20 routers in each city. I am not telling you the bookish definition. I am telling you with an example so that you guys can understand what exactly it is. Okay,
Yeah, sure, sure, sir.
so it's R1, R2, R4, R5, R6, R7, R8, R10. Now Hyderabad also have. So these routers within Mumbai, they are connected with each other. Okay, if we are passing internet data through this network within the Mumbai, so these router will connected with each other within Mumbai. Let's suppose they are connected in this manner or any other manner. It also may be possible that R9 is connected directly with R3 also. It is also possible that R9 is connected with R5. It is also possible R1 is connected with R4. Guys, it is clear? So, because here
Sir
in
also have.
Lakshman, do you have any question?
No, sir, no, sir. Now your screen is full.
Yeah. Okay. So if so for intra-city connect intra-city connection, R4, let's suppose, is connected with R1, and for the getting the backup path, R4 is also connected with R4, and here R7 is also connected with R7, and R7 is also connected with R10, and R10 is also connected with R9, so that intra-city between two cities they can exchange the prefixes. Is it clear? They are connected within cities and they are exchanging the prefixes within two different cities. Now let's suppose in Chennai location they are connected with each other.
Sir, the meeting is about to end, sir.
Okay, one minute. Let me share another slide. My screen is visible, guys, for you.
Yes, sir, visible.
Okay. Now these are interconnected with each other within city, Chennai. And let's suppose this R3 is connected with R4 and this R3 is also connected with R1. Let's suppose this is connected with R7 and R9 is also connected with R7. Let's suppose they are connected with each other. So how can we get to know that these are the different cities router? So for this purpose, we use autonomous system. Here we use autonomous system, if suppose 100, then here we use autonomous system 200. Here we use autonomous system 300. By seeing this autonomous system, we will able to understand this router is this router is from which city? Hyderabad. Okay. This router is from which city?
Chennai.
Chennai. And this router is from which city?
Mumbai.
Okay.
Yeah.
It may be possible. It may be possible. So, let's suppose this is Delhi. So we have South Delhi, Central Delhi, North Delhi. So how can we get to know that which router is from South Delhi, which router is from Central Delhi, which is from North Delhi? It may be possible they are suppose here South Delhi. In South Delhi, all the routers have the autonomous system AS20. Central Delhi AS30. Here AS40. So by seeing this autonomous system, we will able to understand that this this router belong to Central Delhi, this is South Delhi, this is North Delhi. And here we can use in BGP, it's a very, it's called as the BGP confederation. So here we use for entire Delhi, the AS can be as 500. So first of all, you will see the 500, you will able to understand this is a Delhi router. After that, when you will check that in BGP confederation, that AS is 20, under this 500 AS is 20, this it means it is South Delhi router. This means it is a North Delhi router, Central Delhi router. It is a North Delhi router. Did you guys got my point?
Yes, sir. But there are two autonomous systems.
Yeah,
How?
there are two autonomous system. It's a CCIe level 3 things. This is called as a BGP confederation.
Okay, sir.
Okay. In an autonomous, within an autonomous, you have the autonomous. So autonomous system is basically a zone or an area in which we have all routers uh, can aggregate that this autonomous system, this is an autonomous system, and in this autonomous system all the routers with this name, okay, the same autonomous system. So in an autonomous system, especially in EIGRP, how many maximum number of router can we put, how many maximum number of router within an autonomous system, means the range will be 0 to 255, minimum 0 and maximum 255 router can be in a single autonomous system, means for autonomous system 20, maximum range, how many router can we put as AS20? Can we configure more than 255 routers?
No.
No,
No,
sir.
only 256 router we can configure. Is it clear for everyone?
Yes,
In
sir.
EIGRP. So autonomous system is clear?
Yes, sir. But the exact definition for interview.
Exact definition. Let me write down the exact definition. Bookish definition. An autonomous system defines the maximum limit of router which we can put under a zone or area. Is it clear, guys?
Yes, sir.
Yes, sir. Clear.
Lakshman,
Yes, sir.
autonomous system is very important for two, especially two protocols, for EIGRP and for BGP. So let we discuss about EIGR. Enhanced interior gateway routing protocol. It is a Cisco proprietary. Means EIGRP will work on which router? Only work on Cisco router previously. But nowadays EIGRP is an open standard. Cisco has make it as open standard. Now Juniper and Aruba, Alcatel, Nokia can also use the EIGRP. They are using. But in the starting, when EIGRP came, it was a Cisco proprietary. Okay, guys. Are you there?
Yes, sir.
Okay. It is a layer 3 protocol. It's Cisco proprietary and it's a layer 3 protocol. What is the protocol number of EIGRP? Anyone?
88 or 89, something maybe.
88.
Yeah, and 89 for the OSP.
Yes. AD distance
90.
Mm, 90, sir. And for EIGRP external, I think 170.
administrative distance for it is for internal.
Yes, and 170 for the external.
Okay. Anyone knows about the EIGRP multicast address?
224.0.0.10. Whether it's correct, I don't know.
Shubhajit,
Yes, sir, I am not sure. Confusing.
Ravi Shankar, should
What,
I
sir?
give it as a question for tomorrow? I will give a good question for tomorrow, not this type of silly question.
Sure. Okay,
Okay.
sir. Sure.
What is the multicast address? And what is the meaning of the multicast address?
It spread multicast address help to spread the packet to entire network. A multicast address help to spread this packet to entire device present in a network.
Shubhajit, what is the meaning of the
It
multicast
is
address? Why do we use it?
it is the address that can reach in a group of network. I mean, in a network, it can go with many devices to communicate, and it is a unique address.
No, I will tell you tomorrow. So multicast address is what Lakshman you told? 224 dot
0.0.10.
0 dot that exactly.
Correct. Okay.
The sixth point for the EIGRP is what is the use of the protocol number? This is a question
Protocol
for you guys. Yeah, yeah, Lakshman,
protocol
tell me.
protocol number helps to define which protocol is being used in router.
So, in the case of the EIGRP, why do we use it?
Don't know, sir.
I don't know. It is an IGP protocol. Seventh, on which we have discussed. It is an advanced distance vector routing protocol. We have discussed about the advanced distance vector. You guys remember it? What is the exact meaning of the advanced distance vector? We have discussed.
Both link state and distance
Yes.
will be
EIGRP work with 5 messages. First is hello packet. Second one is update. Third one is acknowledgement. Fourth one is query. And fifth one is reply. Okay? They will discuss in detail tomorrow about this packet. The last point is it is a class full routing protocol. But from the iOS version 15, it is a classless. I will show you exactly what is the meaning of the classless and classful. Subhajit, what is the formula to calculate the cost in EIGRP?
Bandwidth and delay.
Yes.
10 power 8 divided by bandwidth
So hello timer is
based on interface. 5 seconds for LAN interface, 60 seconds for WAN interface.
Hello router. Hello mas hello message. Send after 5 seconds. Okay. After each and every 5 seconds, a router will send a hello message to its neighbor. For how much time a router will store this hello message? Anyone who knows?
Don't know.
Should I give you as a question or should I discuss it?
Discuss it, sir. We can note it.
Okay. But I want to give this as a question.
Okay, sir.
If you
Sir,
guys,
scroll up please so we can take the screenshot of these points and later we can write down.
okay, no issue. 1 minute. Let me discuss another 2 to 3 more points.
Okay, sure.
Okay. By default, it supports 4 maximum path. By default, but we can increase this range to 16 and 32. In some routers, we can increase this range to 32. What does it mean? By default, it supports 4 maximum path. Let's suppose, I'm giving an example to you. It's R1, R2, R3, R4, R5. Suppose that n number of router connected with R1. And these router are connected with, suppose that R100. Okay. So by default, R1 will in its routing table will have that path, entire path information in its routing table to how to reach to R100. There are 4 paths, more than 4 paths. It may be possible that 100, 50 paths or 60 paths. So by default, R1 will have only 4 path information. That okay, these 4 paths, with these 4 paths I can reach to R100 if more than, but we can, if we want to store more than 4 paths, we can store up to 16 or 32 paths. If more than 32 paths are available to reach a destination, then by default, how many paths will store router 1 in its routing table? Only 4. Suppose that Lakshman is in Kanyakumari and he can reach to Delhi from Kanyakumari to, there are 70 paths available. Okay. By default, Lakshman will store only 4 path information. He can store up to 16 and 32, but if we want, by default it will be only 4. Did you guys get this point?
Yes, sir.
Okay. You can note down so that I can go on the next slide. Screenshot you guys want. Okay. Let me take the screenshot.
Yeah, sir, scroll.
Did you write down it? All the points? Since fifth point.
Yeah, we I took the screenshot, sir.
Okay. Now from sixth.
Yes, sir.
This point number 8. Everyone, Ravi Shankar, have you
Yes,
written
sir.
down?
Read down, sir.
Okay.
Yes, sir. Change.
So the next point is space is available. It uses dual algorithm to choose best path. I can explain this point, but there is no requirement. No requirement for you guys. Only the interviewer will ask to the DevNet professional to this question. What is a dual algorithm? Or is a DJ Kastra algorithm? Who are coming from a programming background. Okay?
Yes, sir.
Okay. Let me open a new. So, hello timer, what is?
5 seconds.
5 seconds. Whole timer is a question.
Yeah.
Okay? And what is the
Yes.
AD
Actually,
value?
three times, sir, three times of follow interval will be the whole second.
Yes, exactly. 15 seconds.
Then 15.
Yeah, exactly. So, multicast address. Ravi Shankar, what will be the multicast address of EIGRP?
Sir, 24.0.0.0 bar 10, sir.
What will be the AD value?
90 and 170.
Yes. Ravi Shankar, how many messages EIGRP uses?
5 message, sir.
Which one?
Hello, update, acknowledgement, query, reply, sir.
And what is the protocol number of EIGRP?
89. 89.
Protocol number 88 for OSPF.
Sorry. I confused it.
So let me give a questions answer because I don't want to give you the two questions. Why do we use protocol number? So suppose Lakshman, it is the last
Yes, sir.
point for today's class. R1 is sending a packet to R2. Here it is R3. From R1 we are pinging R3. It's a 10 network, it's 11 network. Okay? From R1 to we are sending a packet to R3. When R1 will generate an ICMP packet on layer 3 and it put the information that protocol number is 88 at layer 3. When router 2 will open this packet and get to know that protocol number is 88, then router 2 will able to understand only that on a router router 1 is using EIGRP protocol to send this packet. Lakshman, did you get?
Sir, by saying the protocol number, only router to understand the it is an
Yeah.
EAGRP
In
packet.
in IP header there was an a field protocol number I discussed.
Yes, sir.
In IP header,
Yes, sir.
did you guys remember IP header protocol number?
Yes, sir.
This protocol numbers use here. By seeing the protocol number, a router can understand my neighbor is sending this packet with the help of this protocol. If it is 89, then router 2 will understand, oh, router 1 is using OSPF. Clear?
Yes, sir.
Subhajit, Ravi Shankar.
Yes, sir, clear.
Yes, sir, clear.
So, neighborship type in EIGRP. There are two neighborship type in EIGRP. First one is static neighborship. And second one is dynamic neighborship. Okay, we can configure the EIGRP neighborship statically. I will show you. And dynamic, it's a common process. Okay, there are two neighborship type in EIGRP. Neighborship criteria. It's a very important question for the interviews. What is the neighborship criteria? And each and every point you will have to explain. Router must be in same subnet. Note down these points. Each and every point you will have to explain. Same subnet. The K value will must match, or we can say metric values must be same. The third one is router must be in the same AS number. Okay, authentication must match. Interface should not be passive. Guys, these are the 5 points. Router must be in same subnet. Write down these points so that I can explain.
Yeah,
Uh,
we right.
Sir, could you please repeat the like protocol number in Eigrp. By seeing protocol number only, router understand the type of
Which
what
protocol
like
exactly used by the
neighbor
neighbor
router.
router?
Yes, sir.
Or the sender router.
Yeah, or the sender router. Write down these points.
Yeah, write down already.
Every hello message contain these neighborship parameter. Okay, guys, it is clear.
Yes,
So
sir. So,
must
yeah.
be in same AS number means if we are using AS number 100 here, suppose that on router 1, and on router 2 we are using AS number 200. So it is not possible that these two router can be a neighbor. Okay.
Yeah, yes, sir.
Okay. The second point must be in the same subnet. Means suppose let's suppose R1 and R2, and where we are configuring 12.0.0.1, and here we are configuring 12.0.0.2. If we make a mistake, here we are configuring subnet mask by 30, here we are configuring subnet mask by 28, then they will not become a neighbor in the same subnet only. Okay.
Yes, sir. Here subnet represents subnet mask, not network. Yes, no.
Sub uh, Subnet mask and network both.
Okay, okay.
Okay. Suppose that here R3 we are configuring 12.0.0.1. Here we are configuring slash 28, and here we are configuring 13.0.0.1. It is not possible that they will become a neighbor because they are not in the same subnet.
Yes,
Means
yes.
same
Yes, sir.
network. Means same network.
Yeah.
It should be in the same network only. Okay. The
Yes, sir.
k values, the
Yes, sir.
k values, with the help of k values, we can calculate the cost. And the last one is, fourth one is interface should not be passive. Means it cannot be possible that this interface is should shut down or in passive mode. If it will be in the passive mode, then it will not able to send the hello messages. Okay. So it will be always mandatory that interface should be in no shutdown and will be active, so that it can
Authentication.
yeah, it can participate in the neighborship process. Authentication means if you are using some password, okay, on R1, and you are not using any password on R2, then it is not possible they can become a neighbor. And if you are encrypting a password on a R1 and you are simply applying a password on R2, then it is also not possible they can become a neighbor. So in is means authentication process. Suppose that let's suppose MD5 is a method to encrypt a password. If you are MD5 using on R1, then we should have to use MD5 onto R2. If you are using the keychain method on R1, then we should use R2 to keychain method only. If you are applying any authentication process, means we are applying a password so that everyone cannot access the router. So these parameter also will go within the content of hello message, as I told you, and both router will make a comparison. All the parameters are matching or not. If both hello messages of R2 and R1 will match, then only neighborship will they will become their neighborship. Otherwise, they will not become their neighborship. Guys, clear?
Yes, sir.
So K value is clear for calculation of metric and cost. Router must be in the same subnet. Okay?
Okay, sir.
So these are the points for the neighborship criteria. Any guys, any question do you guys have? Tomorrow I will discuss how they exchange the hello messages, what is the process, and how to calculate the EIGRP metric. And I will discuss about the packets of the EIGRP, messages of the EIGRP, hello update, and partial update. There are three packets: null update, full update, partial update, reply, acknowledgement, query. I will discuss these messages of EIGRP and will show you each and everything in the packet tracer, and by tomorrow I will try to complete it. So if you have any question, you can ask to me.
Sir, could you please tell one more time? There are two neighborship type in AGRP: static neighborship and dynamic neighborship.
Yes,
Correct?
yes. So
Okay.
static neighborship, there is a command difference. I will show you tomorrow. You will not able to understand without the
Yes, sir.
practical.
Yes, sir.
Okay. Traditional method is dynamic, and we can use the static also for preventing the route poison. From route poison, if we want to prevent, we can use the static. I will show you the static. You will not able to understand theoretically unless until I will not show you. So guys,
EAGRP definition one more time. Like EAGRP is used to find the best path from source to destination.
it's a layer 3 protocol.
Uh,
It we used it to make a connection between two routers or two level 3
to find
switches.
the
Which
best path, this definition like EAGRP is used to find the best path.
no, no, no,
Whether this
no, no. You cannot say we are using the EIGRP for the best one.
uh, sir, sorry. Could you please repeat the definition one more time so that I can note it?
EIGRP used to make a connection.
That's all.
That's all between two different router, and
Yes, sir.
EIGRP choose the best path among all present path, and it maximum can store by default 4 path in its routing table, and it can up to 16,
Yes, sir.
and for iOS version 12 and above it can store maximum 32 paths, but below than the iOS version 12 it will use only 16 path. Nowadays we are using iOS version 15, 15, 16. Okay.
Sir, then the classless routing protocol. What is
Yeah,
classful?
tomorrow
Differentiate between
tomorrow I will
classless.
classless and classful by practical only I will show you. You will not able
Yes,
to
sir.
understand it without practical. Okay.
Yes, sir.
Any other question?
Sir,
Yes.
how many days left of our CCNA class?
Yeah. I want to take a class on Saturday also. So you guys will be available. So if you guys will available on Saturday, we will try to complete the entire routing. in this week only, so that in the next week we can complete the switching. And after completing the switching for wireless and network automation, it will take around 5 to 10 classes. And ACL and NAT I will have to cover also.
Okay, sir. As we all are want to crack the CCNA exam, so it will be good that we are following the CCNA syllabus.
Yeah, you should have to follow the CCNA syllabus, and you should have to practice from the CCNA dump.
Uh,
So
Without
are you
practicing from
following
CCNA
CCNA
dumps,
syllabus?
don't go for it.
Sir, like our suggestion is like teach us in syllabus wise so that we will be on track.
You can follow the Todd
Uh,
Lamley book. You can practice
what,
it.
sir?
Todd Lamley book for CCNA.
Spelling?
Todd Lamley. You can write down Todd Lamley. It is available in PDF format. Let me show you the Todd Lamley book. If you want to practice, Todd Lamley CCNA PDF download. This is the best book.
Okay.
Okay, Todd Lamley. You can write down, note down the name, Todd Lamley.
Yeah.
Okay, try to update the download the updated version of the Todd Lamley.
Sir, I have a book by Wendell Odom.
No, Todd Lamley is best. Otherwise, you can download the books which is provided from the Cisco, from Cisco's website. I will show you tomorrow
Okay.
how to get the books from the Cisco's website. Before going for CCN exam, practice from this book because it has MCQs question and number of subnetting questions. So you can do the practice from the Todd Lamley book.
And sir, the dams, do you help us to provide these dams?
Try to help you. Try to help you. Will try to
Okay.
help you to provide the dumps. I will have to ask to someone also. That is why I am saying.
Okay.
Okay,
I
sir.
don't have the
Thank you.
dumps, but I will try to help you. I will have to ask to someone. Anything else? But guys, if you
No.
are going for the CCN examination, make sure that you have practiced the entire Todd Lamley book, and I will give you the books from the Cisco's Pearson's book. In Todd Lamley,
Like we need to,
routing and
sir, we
switching
need to.
both in the same book, but you will get the routing and switching in the different books from the Cisco.
Sir, we need to like how to read that book. We need to read line by line, or there will
Yeah,
be any.
is there any other method?
No, I'm asking whether
Yeah,
there is.
yeah, you cannot make a shake of that book. Okay, so you will have to follow the same formula.
Sir, do you have any tips? Because you do certification in
Yeah,
CCNA, yes, no?
yeah, you will have to read down each and every line.
Okay, okay.
There is no other way. Okay, guys, thank you. Any other questions?
No, sir, no.
Okay.
Bye bye.
Yes, sir. Thank you.